to the second half of page 1 for the Benchmark 3 study guide, and question number 6 is asking us about solving absolute value equations or inequalities. It could be either type. So let's take a look at the first one here. So this one, we want to isolate the absolute value. So the first thing I'm going to end up doing is subtracting the 3 from all sides. And so when I do that, I'm left with this negative sign on the outside of an absolute value bar. Inside the absolute value bars, I have x plus 3 is greater than or equal to negative 11. And then I have to divide by a negative 1, and that will take out this negative sign in front of the absolute value bar, but I have to do the same thing on the other side. And so when I do that, I'm left with this x plus 3 is now less than or equal to positive 11. I still have the x plus 3 in the absolute value bars. Notice that the inequality signs switch directions when I divide it by the negative. Now we can go ahead and set up our two problems. We're going to end up with x plus 3 is less than or equal to 11, but it's going to be greater than or equal to negative 11. And so when I go ahead and solve, I need to just subtract the 3 from both sides, and I'll have my two answers. So when I'll do that over here, I've got negative 14 is less than or equal to x, and x is less than or equal to 8. And that would be the answer that we'd end up seeing. They could end up having it in the graph form, which would be a number line with negative 14 on one side, 8 on the other. It's a closed circle on the negative 14 and 8 because they equal, along with being x values have to be greater than 14, negative 14, but less than 8. So it goes together. That's called a conjunction or an and statement. The next one, we're going to end up dividing by 2 on both sides first. And I've got this x plus 1 is, in the absolute value bars, is greater than 2. So now I set up my two problems. I'm going to end up with an x plus 1 is greater than 2, but less than negative 2. So I just have one final step of just subtracting this 1 from both sides. And I end up with these two numbers. I end up with a negative 3 is greater than x, which is greater than 1. However, you're not going to see the answer this way because the values of x are bigger than 1. So if I graph this, notice that they're larger than 1, they're going this way, but they are smaller. X is less than negative 3. And so this is an OR statement. So OR statements are going to be written as two separate inequalities. So it would look like this. X is less than negative 3, or x is greater than 1. And that's the way you're going to end up seeing the answer. So this next one, you just take that 2x plus 1, you set it equal to 11, and you also set it equal to negative 11, because those are the two values that you could end up with underneath the radical sign once you solve for x. And so we're going to go ahead and subtract the 1 from all sides. When I do that, I end up with a negative 12 is equal to 2x, which is also equal to 10. And so I go ahead and do some division of 2. Divide by 2 on all sides. And I have my answers. Negative 6 equals x, but it also equals 5. So those are the two values for x there. On this next one, whenever you've got a proportion, when a proportion is two fractions set equal to each other, you can cross multiply. That'd probably be the fastest way to do this problem. And so the other way is to just multiply by a number to cancel out the 2 and the 3, like 6. But you see, if you put 6 up here, 3 goes into 6 2 times. So you'd end up multiplying 2 by these two numbers, and that's what we're going to be doing here when we cross multiply. So I've got now 2 times by 3x plus 1 equals 3 times by 5x minus 2. And so we go ahead and use the distributive property, distribute the 2 over those two numbers and the 3 over these two. And now we've got a 6x plus 2 equals, and then we've got 15x minus 6. So we go ahead and do some opposite operations, maybe subtract the 2 from all sides, subtract that 15x from both sides, and then we've got this. We've got a negative 9x equals negative 8. And so when I do that division, dividing by negative 9, I'll have my answer. So it's just a fraction. The negative signs cancel, but that's it. So just just 8/9 is your answer. Taking a look at the next one here, we've got the distributive property we have to do first. 2 times these two numbers. On this side, you got to do the -5. Watch the sign there, -5 times these two numbers. So we end up with a 4 plus 4 minus 16y. And then that's greater than or equal to 3 minus the 45 plus the 10y, plus because of the two negative signs. So we'll go ahead and collect some terms. So anything that has the same variable raised to the same power, we're going to go ahead and collect. So both constants will be added together on each side. So we end up now with an 8 minus 16y is greater than or equal to, this makes a -42 plus 10y. And so from that point, we can go ahead and do some opposite operations now to isolate the variable. So I'll go ahead and add this 16 to both sides, 16y that is, and then I'll add this 42 to both sides. And now I've got 50 is greater than or equal to 26y. And so all I have to do now is just divide by the 26. Well, 26 doesn't go evenly into 50, but there's a common factor that I can take out. So I'll go ahead and do that. So I'm going to take out a 2 from each of these numbers. So my answer is going to be y. Now notice the inequality sign, it's pointing towards the y. So less than or equal to 25 over 13. That's my answer. So let me fix that so you can see that a little bit better. 25 over that 13. There we go. So the next problem, what we're going to do is distribute that 2 over these two numbers. Same thing here. Watch that -2. Got to distribute it over the two numbers inside that set of parentheses. So we end up with a 6x minus 16 equals 5, and then a minus 12 plus because of the two negatives there, plus 10x. So we can go ahead and collect some like terms just on the right-hand side this time. So now we still have this 6x minus 16 equals -7 plus 10x. So now we can start moving terms around from one side to the other. So I'll go ahead and subtract this 6x from both sides. And I'll also add this 7 to both sides. And so when I do that, I have -9 now equals 4x. So all I have to do is do a division problem. Divide by 4, and we'll have our answer. -9/4 equals x. We can just leave the answer like that. So taking a look at the next one. Here we have a distributive property. Again, we've got to use, and then here you see the minus sign and then the parentheses. Think of this as like -1. And you're going to distribute the -1 over those two terms. So when we do that, we've now got a -2x plus 16 equals 3 minus 3x minus 2. So we can go ahead and collect some like terms, if at all possible, and we can on the right-hand side. So bring over that 16, that -2x. It's just the 3 and the -2, which make just 1 minus 3x. So all we have to do from this point is move terms around. So I'm going to end up adding this 3x to both sides. And I'll also subtract that 16 from both sides at the same time. So I end up with x equals -15. That is our answer. Well, 2 more problems. Let's take a look at this first one here. We've got a rope is cut into 3 pieces. And so if you think about the rope, here's the rope cut into 3 different pieces. The second piece, so this piece here, we'll call this 1, 2, and 3. The second piece is twice as long as the first piece. The third piece is 3 times as long as the first piece. Notice that they're comparing to the first piece each time. So let's call the first piece x. Then the second piece is twice as long as the first, so 2x. The third piece is 3 times as long as the first, so 3x. So the key is to figure out where to put the x, is to see which one they're comparing to each time. So this time they're comparing the first piece to each of the other 2 pieces. So they want to know what is the length of the longest piece of rope that was originally 180 pieces before being cut. So what we're going to do is do x plus 2x plus 3x equals 180. So we go ahead and solve for x by combining like terms. 1x and 2x plus 3x makes 6x's equals 180. So we divide by 6. This gives us x. So x equals 30 feet. But we don't want that piece. That's the shortest piece. The longest piece is going to be the one that is multiplied by the bigger number. So 3x, this is the longest right here. And so what we'll do is take that 3, multiply it by 30, that gives us 90 feet. That's the longest piece. Next problem talks about Ed bought 3 boxes of oranges and 1 box of pears. So boxes of oranges. So we are probably going to have 2 unknowns. Let's see here. He spent $24 and the box of pears cost $3. Oh, they tell us that. So let's write an equation first of all. We'll say O stands for, instead of O, let's use R. Say R stands for oranges, and let's go with P for pears. So we've got 3 boxes of oranges, R, and 1 box of pears, P, and he spent a total of $24. So R stands for the cost of the box of oranges, P stands for the cost of the box of pears. Well, they tell us box of pears cost $3. So let's put this 3 in place of that P right there. So now we have 3R plus 3 equals 24. So all I need to do from this point is move this 3 back to the other side. So I need to subtract it. So it gives me 3R equals 21. And then I can divide by 3. And that gives me my answer. R is $7. So let's see if that's what they wanted. Find the cost of 1 box of oranges. And that's it. Oranges cost $7 per box. Well, those are the problems on the first page. You can check out other parts for other pages and problems.